This is section 3.4 on linear and angular speed. Let's review a little bit. If you remember, distance is equal to rate times time formula. And do you remember how we could solve this for the rate by dividing both sides by the time? So then the rate is equal to the distance over the time. Well, we're going to follow the same formula, just using different variables when we look at linear speed. So let's look here at linear speed. Suppose that a point P, so that's this point here, moves at a constant speed along a circle of radius r and center O. The measure of how fast the position of P is changing is the linear speed. So the linear speed measures how fast this point P, the position, is changing. We use the formula speed is equal to distance over time, and instead of using r for the speed, we're going to use v for the velocity is equal to the distance, which is s, and you see that's the length of the arc, divided by the time t. So the linear speed is the distance divided by the time. The angular speed, this measures how fast theta is changing over time. So the angular speed, and we write that as omega, so omega is equal to theta over t, where theta has to be in radians, not degrees. You're taking the radians divided by the time to get the angular speed. Here theta is a measure of the angle POB, so that's this angle here, at time t. And as with earlier formulas in this chapter, theta must be measured in radians. So omega will be expressed in radians per unit of time. So just so we can denote the difference, the linear speed is the change in s over t, and the angular speed is the change in theta over t. Look at this chart, the formulas for angular and linear speed. Omega is equal to theta over t. And theta has to be in radians. The linear speed, v, is equal to s over t, where s is the length of the arc. Well, do you remember the formula that we used in the previous sections? S is equal to r theta. Well, then we could write the linear speed in terms of r and theta. So this would be r times theta over t, just replacing the s with r theta. And then we know that omega is equal to theta over t, so do you see how we could replace the theta over t with omega? So v is equal to r times omega. Or in words, the linear speed is equal to the radius times the angular speed. I'm going to use these formulas in the next few examples.